Hello everyone, this is Srimana and welcome to Genius Mathematics. In this video, we will see how to graph quadratic equations. So first, we'll see three equations. First, x square minus 2x plus 1. So the equation is x square minus 2x plus 1. So first what we need to do is put y equals x square minus 2x plus 1. Now, we'll simplify this as a factor of two linear equations. So from this we clearly see x minus 1 and x minus 1. We can factor this as this. So x minus 1 times x minus 1 gives x square minus 2x plus 1. So next what we should do is differentiate this equation with respect to x. So we get 2x minus 2. And we need to put y dash equals 0. So why we do this is to find the minimum or the maximum value of this function. So put y dash equals 0. So 2x minus 2 equals 0, x equals 1. So again differentiate this. So y double dash equals, differentiate this with respect to x gives 2. This is greater than 0, which means minimum. So what this means is, this graph or this function is minimum at x equals 1. So this is what this means. So substitute x equals 1 in this equation. We get 1 minus 2 times of 1 plus 1 gives 1 minus 2 plus 1 gives 0. So this function, the lowest point of this function is 1, 0. So these are the things we want to graph a function. So now we will graph this function. So let's say this is the graph. So first we have the minimum point at 1, 0. So at 1, 0. So this is the minimum point of this function. So behind or lower to this there will be no curve for this function. So next, x minus 1 and x minus 1. So this is where for x equals 1, it coincides the x-axis. So that point is same for this function. So 1, 0. So this is the least point and this is the point where the function meets the x-axis. So next what we will do is put x equals 0. So why we put x equals 0 is for finding the intercept on the y-axis. So if we put x equals 0, we get y equals 1. So this is where the function meets the y-axis. So here we have 0, 1. So we can draw the curve like this. So this is how the curve will be for this function, x square minus 2x plus 1. So this is for the first question. So now we will do the second one. So we will do the same thing with the next problem. First the function is x square minus 5x plus 6. So put this as y. So first we need to separate this into two product of two linear functions. So this we will do, if we multiply two numbers we get 6. If we add two numbers we get minus 5. The two numbers are minus 3 and minus 2. So we can write this as x minus 3 and x minus 2. So next we need to differentiate this. So we differentiate this, we get 2x minus 5. So this is what we get. So next we should do y dash equals 0 to find the critical points. So if we substitute y dash equals 0, that is 2x minus 5 equals 0, x equals 5 by 2. So x equals 5 by 2. This is the critical point. Now we differentiate it again. So we get 2. This is greater than 0, which means at x equals 5 by 2 is the minimum point, because 2 is greater than 0, which means the minimum point is at x equals 5 by 2. So the critical point is x equals 5 by 2, and this is the minimum. So if we substitute 5 by 2 in this equation, so we have 5 by 2, so 25 by 4. So substituting this in this equation, minus 5 of 5 by 2 plus 6. We have 25 by 4 minus 25 by 2 plus 6. Taking LCM, so 4 is the LCM, so we'll take, or we will multiply this with 4. So 4, 25 minus, so multiply this with 2, 50, multiply this with 4, so 24. So we get 49 minus 50, so minus 1 by 4. So this is where the least point is. So the least point is at x equals 5 by 2 and y is minus 1 by 4. So this is the least point. So now we will graph the function. So for graphing the function, we know the x-intercepts, that is at x equals 3 and x equals 2. So this is 2, 0. This is 3, 0. And this is 2.5, minus 1 by 4. So this is between these 2 points and it is here. So this will be minus 1 by 4. So this is where 2.5, minus 1 by 4 will be. So for excess accuracy, we can find the y-intercept. That is, put x equals 0 in this equation. Y equals 0, 0 equals 6. So the point is 0, 6. So 0, 6. This is the point. So we will draw a curve. So this will be the function x square minus 5x plus 6. So this is the curve for this function. Now for the final function, we will do the same method. So the function is minus x square minus 4x plus 5. So we will put the function as y. We will first keep this function as a product of two linear functions. So if we multiply, we will get minus 5. If we add two numbers, we will get 4. So the numbers can be 5, minus 5 and 1. So divide this with minus 1 because that is the coefficient of the x square term. So the values are 5 and minus 1. So x plus 5, x minus 1. So this, if we multiply this, we get x square plus 4x minus 5. That is the opposite of this. So what we can do is we can put a minus here. So this is what we have here. Or we can do minus inside the term, inside one of these terms. So y can also be x plus 5. We have written the same thing here. For this I will write 1 minus x. That is putting this minus and distributing this minus here. So this is the separable factored term. So differentiate y. So if we differentiate, we get minus 2x minus 4. Put y dash equals 0 to find the critical points. So minus 2x minus 4 equals 0. Minus 2x equals 4. X equals minus 2. So we differentiate this again. So we get minus 2. This is less than 0, which means the maximum point is at x equals minus 2. So if we substitute x equals minus 2 in the function, so we will substitute that y equals, if we substitute minus 2 here, minus 4 minus 4 times minus 2 gives 8 plus 5. So this gives minus 7. So y equals minus 7. So the maximum point is minus 2 comma minus 7. So this is the maximum point of this function. So now we will graph the function. So the x-intercepts are minus 5. So minus 5 comma 0, this is 1, and 1 minus x. So 1 comma 0. So this is another intercept. So this is the x-intercepts. Now minus 2 comma minus 7. So minus 2 comma minus 7 will be right here. So if you want to check minus 2 comma minus 7 fits in this equation, we can do that. So put minus 2 here. So we get minus 4 plus 8 plus 5. So the correct answer for this is, because we have plus 8 here, so the value will be 13 minus, so we'll get positive 9. So we get positive 9. So the maximum is actually minus 2 comma 9. So this is the curve. So this is how the curve will be. So this is how the curve will be. For more accuracy, we can find what the y-intercept is. So put x equals 0. So we get y equals 5. So this will be 0 comma 5. And that's how you will graph the quadratic equations as is in a graph. So why this function is in the opposite direction of u is because we have a negative sign in front. So that is why this is in the opposite direction as compared to these two equations. And that's about graph of quadratic equations. Thank you.